So question 8492 asks us to refer to figures 21 through 25. What is the en route time of the cruise leg for operating conditions BE34? Now, this is kind of a long problem. There's a lot of steps to it, but luckily the steps are relatively easy. So this is going to be a little bit of a longer video, but I'm going to show you a couple different ways to do crosswind component. That way that you have some options, so whatever works for you is totally fine. Now, the very first thing we want to do is go ahead and outline what our operating conditions are. So we're working with BE34. Now, whenever a question is asking you the en route time of something, most of the time it's asking you for that airspeed considering a wind component. So the first step in this problem is going to be to find our wind component. Now, once we find the wind component, let's go ahead and look at our other charts that we have here so that we know what we're going to expect. So step one is going to be that wind component on figure 22. I'm going to show you an additional way to find your wind component using your E6B. And then we'll move on. There's 3 charts here, which seems like a lot, but really you're just choosing which chart to use. And you're choosing that based on whether you're ISA minus, ISA, or ISA plus. And then once we have that chart chosen, now we're going to look a lot more closely and figure out what we're actually burning and how fast we're actually going considering the wind component. So step 1 is to find the wind component. Now, the easiest way to do this is to use your E6B. You have wind that's given to you right here, 340 at 25 knots. And then you also have a true course of 0 to 0. And you're going to need both of those things for your wind component. So in order to use figure 22, you need to figure out the angle of distance between the runway or your true course and the wind. And the easiest way to do that is to come over to your E6B. And what you're going to do here is you're going to set your true index to whatever your true course is. So I already have mine set to 0 to 0. I'm just going to draw a line down the center of my E6B. And this is going to act as my plane. Like here's the tail and here's the nose. Now on your own E6B, you can use a pencil or a pen or a dry erase marker. Anything but a Sharpie will erase from the E6B, so feel free to write on that. And then my next step is I'm going to draw a line from the wind direction. So wind is coming from 340, so the wind is coming at me like this, and it's hitting my aircraft this direction. And so to figure out that angle, all I'm doing is I'm legitimately counting from 340. So 1, 2, 3, 4. That's 40 degrees of difference. Also, you can look up here and it will tell you the degree on the top. So I know that I have 40 degrees of difference. I'm going to go ahead and write that over here, 40 degrees of difference. And now looking at this chart, figure 22, this chart is laid out so that the angle of the wind and the runway are the lines that kind of shoot up like this. I'm not even slightly on that line. There we go. And so that's 30 degrees of difference, 40 degrees of difference, 50 degrees of difference, so on and so forth. And then your wind velocity are the lines that go across. So that's 55 knots of wind velocity over here. This is 30 knots of wind velocity right there, and 25 knots of wind velocity. So what I'm going to do is I'm going to go ahead and find where those lines meet for me. And let's erase this so that it looks a little bit cleaner real quick. You can highlight or mark what your wind velocity is. So I'm going to mark 25 knots like this. And I'm going to go ahead and mark my angle of difference. That's 40 knots right there. And then wherever those two lines meet, I'm going to zoom in. Wherever those two lines meet right about here, I'm going to go ahead and draw a straight line directly across. And wherever I end up, I'm a little low there, but probably end up somewhere like that. But I'm going to have about 19 knots of wind. So I'm saying 19 knots. To figure out if it's a headwind or tailwind, again, you can come back to that E6B and just remember if your angle is above halfway, you have a headwind. And if that wind component is coming from, what did we just do? There we go. If that wind component is coming from down here, it's a tailwind. So we can tell up here we have a headwind. So I'm going to say that I have 19 knots of a headwind. There is another way to determine our amount of headwind, and that's using the E6B. This is my preferred method. I think that it's a little bit easier and you can use it throughout the rest of the course. So you've already done what you needed to do on this side and determined that you have 40 degrees of difference between your wind direction and your course. Now, if you flip to the back of your E6B, you should see a chart that looks like this. If you look at the bottom, it tells you exactly how you read the chart with headwind or tailwind. It can be either, depending on the wind direction, on the top and then crosswind on the bottom. So for us, we can go ahead and disregard crosswind because that's not going to be relevant in our en route calculations. What we're going to do now is we're going to find our angle of difference on the top. And then on the side, we have 25 knots of wind. So we're going to have to figure out how to get 25 knots. So what I like to do is I like to first take 20 and figure out what my wind speed is going to be, my wind component with 20 knots of wind. So I just find the box that these both lead to, and I'm taking that top number of 15. So I have 15 knots of wind right now, but I need to account for 5 more knots of wind because I had 25. In order to do that, I think the simplest way is to take 10 over here, get the number that correlates with 10, and then in order to get 5, you can take 10 divided by 2, that'll give you 5, and so if you're doing that over here, you're also going to take 8, divide that by 2, it's going to give you 4, and so for 5 knots of wind at this angle, you would have a 4 knot wind component. I'm going to take that 4 and add it to my 15, and that gives me 19 knots. And you can see that I get 19 knots using this method and I get 19 knots using the chart. So either of these methods work totally fine. You can choose whichever one you feel is the simplest. So once we figured out the wind component, we can go ahead and move on to determining which chart we're going to use. Now, in order to figure out which chart we're going to use, we need to figure out if we are ISA minus, ISA exactly, or ISA plus. So the very first thing we have to do is determine what ISA is at our altitude. So our altitude over here is given to us and we are at 23,000 feet. So we're going to take 23,000 and we take 23 times -2. That is going to give us -46. And then we have to add 15 in to account for standard temperature, and that will give us -31 degrees. Now that we've figured out that ISA at 23,000 is -31 degrees, we're going to look at our operating conditions and see what exactly our temperature is. And if you refer to your operating conditions, it tells you that the temperature outside is -31. So we are neither plus or minus ISA. We are exactly ISA. So we're going to be using this figure here, figure 24. Now, once you calculate this, if your temperature outside is warmer than -31, you would be ISA plus. If it's colder, you would be ISA minus. So if you want to make a note of that, you totally can. This chart would be for warmer. This chart would be for colder. And now that we've determined the chart we're going to use, we can go ahead and start looking exactly at our chart. Now, we need to figure out what we're going to find or what our true airspeed is. So what section of the chart are we going to use? Our operating conditions tell us that we are at 16,000 pounds. So we're going to highlight 16,000 pounds. That's right here. We're going to be using this box. And then we have to figure out our pressure altitude. Our pressure altitude, as we know, is 23,000. So we're going to be between 22 and 24,000, so somewhere here. And we need to figure out our true airspeed. So to find our true airspeed, we have to interpolate between these numbers right here. And so we're going to do that. We're going to take 233 plus 223. So 233 plus 223. And that's going to equal 456. We're getting an exact middle number at 23,000. So luckily we don't have to do crazy math for this. We can get kind of the median number and that will work for us. So I'm going to take 456 and divide it by 2. So 456 divided by 2, and that's going to give me 228. So 228 is going to be my median true airspeed for flight level 230. So my true airspeed at flight level 230 equals 228. So to find the ground speed, we have to apply our wind component. So we're taking 228 and we're subtracting 19. So 228 minus 19 is going to give us 209. 209. So we know our speed. We're moving 209 knots over the ground. Our distance is 230, and remember that we get that from the operating conditions. It tells us exactly how far we're going. So our distance is 230. So to find the time it'll take to cover 230 nautical miles, we're taking distance divided by time times 60. So I'm taking 230 divided by 209, and then I'm multiplying that number by 60. So we pull up our calculator here, and I'm taking 230 divided by 209 times 60. That's going to give me 66 minutes. And then if we figure out what's next, we're taking all of our answer choices are in 1 hour and blank minutes. Well, 66 is 1 hour and 6-ish minutes. We're saying ish because there's a lot of decimal points after that. So 6-ish minutes. Once we figured that out, we're going to go look at our answer choices over here. And amazing, we have answer choice A, 1 hour and 7 minutes. So while this is a lot of steps, as long as you can figure out your crosswind component here on this page and then ISA, all you're doing after that, this is your distance, speed, time chart. So that is pretty simple once you can break it down. And that is question 8492 done.